Today we're going to be solving this question. It was question 5 in the AASL exam from last month, and the same question also appears in the high-level exam as question 4. Here this question is trying to be a little extra by having two different circles with two different radius. But the point of the question is that you don't know the radius, you don't know the angle, and you have the area and the perimeter of a sector. You want to find out the radius and the angle. And this is a paper 2 question, so at some point we might pull out a calculator to solve an equation. But basically, it is about solving a system of equations. And the reason why we're talking about this today is that in the previous video that I posted, which was a lot of things about systems of equations, I was saying that for the situations in that video, adding lines to other lines is far superior to the method of substitution, and that if substitution is your favorite method for solving systems of equations, then you're going to want to change your mind. But also, there are other situations, such as this one, in which the other method, adding lines to each other, is not really going to do anything because this system of equations is not linear. Because even though you've probably learned them both for the first time at the same time as options, you were talking about linear systems back then. And the time when the method of substitution really shines is when the system is not linear, because then it becomes your only option. And listen, this question here is a fairly natural question to ask, okay? You have a circular sector, it has a radius, it has a theta, it has an area, which you know, and the perimeter is this here because it's the arc length. Theta r is this side, and the two r's are this r and this r, so we went around the whole sector, and that is the perimeter. So in general terms, the method of substitution goes like this. You isolate one of the variables in one of the equations, and here clearly you're going to have 4 choices of how to do that because it's 2 variables and 2 equations, and you can pick which one you want to isolate where. Then whatever you chose there, you're going to take the result from that isolation and substitute it into the other equation. And it is important that you do it in the other equation. You can't do it in the same one. That is going to basically eliminate one of the variables. So now you have one equation in one variable, which you can just solve. And now you have a number for one of the variables. You just plug it back into wherever you want at this point to find the numeric value of the other variable. So here's the thing, there's 4 choices, and today we are going to do all 4 to compare them, see what's easier, what looks nicer, so that if you do this enough times, you start to see beforehand which one's going to be easier, so you don't really have to waste time in your exam doing all 4 options, okay? Okay, here we go. Here are the 4 options. This is theta in the first equation, r in the first equation, and then both of them in the second equation. Okay. So solving for theta here, we're going to start by multiplying by 2, and then we are going to divide by r squared. Solving for r in the same equation, we also start by multiplying by 2, but then we divide by theta instead. And to continue from here, you see that this r is squared, so you have to take the square root on both sides, and whenever you do that, you have to make that plus or minus appear. Solving for theta in the second equation, we start by subtracting 2r and then dividing by r. Separate the fractions like this if you want. It's not clear right now if that's going to be useful. But to solve for r in the second equation, first you need to factor it out because it is a common factor of both terms on the left side, and then you divide by theta plus 2. Now that we've done all that, let's choose our favorite and from where we are going to continue solving the problem. Definitely not this. This has a square root and a plus or minus. This is horrible. I don't want to work with that. Any one of the others is fine, really. Some people would say that they don't like this one because they don't feel comfortable with the factoring out step. There is a case to be made for it though, because in the original question, letter A asks to find the value of theta. So he wants theta first. He's not so interested in the radius as he is in the angle. And out of the 3 options that I have right now, this is the only one who is first going to give me theta. The other 2 are going to give me the radius first, which is fine. I could just come back to substitute again and find the other variable, which is the theta that I actually want. But for today, I think I am going to take the hint that the question is giving me that this is probably the best place to go. So I need to substitute this into the other equation, and the other equation is the area of the sector. So this was the equation. I am going to plug my R into that. And if you're doing it as a paper 2, this is the moment to put this into your calculator, okay? Don't try to oversimplify things. It is very powerful that in paper 2, any equation in one variable that you want to solve, you can just use the same method no matter what the equation is. So there really is no reason to try to simplify the equation. But today I'm trying to do it by hand. I want to avoid pulling out my calculator if I can. So I am going to do some simplification here. I am going to multiply both sides by 2. Now I'm going to multiply by this denominator. Divide both sides by 100. That makes the numbers a lot smaller. And can you see it? It is a quadratic equation. Whenever we find a quadratic equation, we are happy because we know how to solve them. So this didn't technically need to be a paper 2 question. They made it as paper 2 so that they wouldn't have to worry about ugly numbers appearing in the solution. I'm going to power through the ugly numbers though. I just need to organize my quadratic equation a little bit. I don't think this factors, so I'm going to complete the squares. Continuing on the side here, theta minus 6 squared is 32. Square root of 32 is 4 root 2. Theta equals 6 plus or minus 4 root 2. And here's the thing. Quadratic equations make us happy when we find them because we know how to solve them. But quadratic equations also tend to have two different solutions, like what just happened here. And problems such as this one tend not to have two options for the solution. Usually when the question wants there to be multiple possibilities, he says something like find the values. He uses a word in the plural or something like that, which in this case he very much did not. He said find the value of theta, so there should be only one. So we had our quadratic equation, we solved it. Now here are the two solutions. We have to choose between them. One of them is going to be right and the other one's going to be wrong. And where a lot of students make a mistake in this point is that they too quickly choose the solution with the plus. Because this is a geometry problem and theta is an angle. Well, angles can technically be negative if you go around the unit circle in the other direction, but that's not usually what we mean by an angle in a triangle or in a circular sector. So a lot of students tend to discard very quickly the negative solution. However, the square root of 2 is something like 1.4. It is definitely less than 1.5, and 4 times 1.5 is 6, which is the same number that we have here. The moral of the story is both of these solutions are positive. You are not getting a negative angle anyway, so that is not the problem with one of the solutions. It's got to be something else. And the problem is the opposite. The problem is that the solution with the plus is too big. It is 6 plus 4 times 1.4. This is almost 12. 12 radians? What is that? It's almost twice around the whole circle. So that is the wrong solution, not the one with the plus because it's positive. They're both positive. The correct solution is the one with the minus because the other one is too big. This is the answer. And now in order to complete actually the exam question, I am going to go ahead and find R. But I'm not really going to finish the exam question because remember I told you this question was being extra. He doesn't want you to find the radius of the same circle. For some reason, he's asking about the radius of a different circle. But I'm not going to do that, okay? I'm just going to find the radius of the same circle because I think that is more natural as a question to have a sector that you had the area and the perimeter, and then you want to find the radius and the angle of that sector. Anyway, we're going to plug in the theta into, we had a lot of options of where to plug it in. I just happened to choose this one. So it's theta plus 2, which makes this 8 minus 4 root 2. I can simplify by 4. And then just to be very pretty, I'm going to rationalize this denominator. I absolutely did not need to do this, okay? This was a paper 2 question and things would have been rounded to 3 significant figures a lot earlier than this. I'm just doing this because I want to. I can simplify by 2 again, so 10 plus 5 root 2 would be the final answer for the radius that the question didn't even ask. And the funny thing is that if we had made a different choice in the beginning, if we had chosen either this one or this one, which would give us the radius first, even though the question was asking for the angle, these two would also result in quadratic equations. They would also result in two different values for r, one with the plus and one with the minus. And the thing is that in that situation, you wouldn't necessarily have a way to tell them apart, which one is the correct one and which one was wrong. In the angle, we had an argument about the angle being too big. It was going more than once around the whole circle. But the radius of a sector can really be as big as you want. Maybe you would be lucky that one of the solutions would give you a negative radius, in which case, of course, that's the wrong one. But I don't think this happens in this case. So try it out. Let me know what happens.